Hello everyone, welcome to VCIA training course. The focus of this course is on the training of PPPoE, DHCP, VLAN in access networks. This course will be divided into 4 parts. Introduction to the PPPoE protocol. Introduction to the DHCP protocol. Introduction to VLAN in access networks. And a final question and answer session. Now, we will start learning the first part of this course, the PPPoE protocol. Before learning the PPPoE protocol, it is necessary to understand its usage scenarios, so that we can better understand its practical application in the network. In addition, we need to grasp the working principle of PPPoE protocol, such as how it establishes a connection between user devices and networks, and how data is transmitted. Understanding these basic concepts will lay a solid foundation for further learning and practice. Point-to-point protocol over Ethernet. PPPoE. Integrate the scalability and management control functions of the most economical long technology Ethernet and point-to-point P2P protocol. Generally, in traditional Ethernet network, access network, or PON system, network service providers and telecom operators can use reliable and familiar technologies to accelerate the deployment of high-speed Internet (HSI) services. PPPoE make it easier for service provider to provide broadband access services that support multiple users using digital subscriber lines and wireless connections. Let's see what is the objectives of this part. After this lesson, you should able to describe the concept of DHCP and describe the PPPoE session establishment process. We will go deeper into the PPPoE protocol from the following 2 aspects. Concept introduction of PPPoE and PPPoE session establishment process. Here is the concept introduction of PPPoE. The PPPoE protocol provides a standard for connecting multiple hosts in a broadcast network, such as an Ethernet, to a remote access concentrator, also called a broadband access server. In this network model, each subscriber host needs to independently initialize its own PPP protocol stack. In addition, using features of the PPP protocol, subscribers can be charged and managed on a broadcast network. To establish and maintain a P2P relationship between hosts and access concentrators on a broadcast network, a unique P2P session must be established between each host and the access concentrator. Next, we will introduce the PPPoE session establishment process. Here you can see the description of discovery phase, session phase, session termination phase. Discovery phase obtains the peer Ethernet address and determines a unique PPPoE session. Session phase consists of 2 parts. PPP negotiation phase and PPP packet transmission phase. Session termination phase sends a packet to terminate a PPPoE session at any time after the session is established. When a host wants to start a PPPoE session, it needs to perform a discovery process to identify the MAC address of the peer, and then determine a unique PPPoE session LD. To serve this purpose, the PPPoE uses a discovery protocol based on the client or server model. Due to the broadcast feature of the Ethernet, the host client discovers all access concentrators servers in this process, selects one of them, and establishes a P2P connection with the peer according to the obtained information. After a PPP session is set up, the PPPoE discovery phase is complete. After PPPoE discovery phase, following is session phase. In this part, the host and the access concentrator transmit PPP data based on the PPP protocol to perform PPP negotiation and data transmission. The data packets transmitted in this phase must always contain the session identifier determined in the discovery phase. In normal cases, the session phase is terminated by the PPP protocol. However, a PADT packet is also defined in PPPoE to terminate sessions. The host or access concentrator can terminate a session by sending the packet at any time. Here is the most common packet in PPPoE. PADI, PPPoE Discovery Initial Packet. PADO, PPPoE Offer Packet. PADR, PPPoE Request Packet. PADS, PPPoE Session Acknowledgement Packet. And PADT, PPPoE Termination Packet. Here is the example of PPPoE process. Generally, a single user or a home user uses PPPoE to access the Internet. After passing radius authentication, the user obtains an LP address from the browser. 1. The client sends a PADL packet to the server to start PPPoE access. 2. The server sends a PADO packet to the client. 3. The client sends a PADR packet to the server. 4. The server generates a session LD and sends it to the client through PADS. 5. The client and the server perform LCP negotiation to establish a link layer connection. In this case, CHAP authentication is used. 6. The server sends a 128-bit challenge packet to the authentication client. 7. After receiving the challenge packet, the client performs the MD5 algorithm on the password and challenge. After that, sends the password and challenge to the server on the response packet. 8. The server sends the challenge and username to the Radius server for authentication. 9. The Radius server determines whether the user is authorized based on the user information and sends an authentication success or failure packet to the server. If the authentication is successful, the AAA server sends a message carrying negotiation parameters and service attributes to authorize the subscriber. If the authentication fails, the process ends. 10. The server returns the authentication result to the client. 11. The user performs NCP, such as IPCP, negotiation and obtains the planned parameters, such as the LP address, through the server. Following is the PPPoE process in Wireshark packet capture. 1 to 4 is discovery phase. 5 to 19 is session phase. 20 to 22 is session termination phase. Next, we will begin the second part of this course, the DHCP protocol. Similarly, we need to first understand the usage scenarios of the DHCP protocol. As the network scale expands and the network complexity increases, network configuration becomes more and more complex. In addition, the number of computers and mobile devices, such as mobile laptops or wireless terminals, increases sharply, causing frequent IP address changes and insufficient LP resources. The Dynamic Host Configuration Protocol, DHCP, is used to dynamically allocate LP addresses to hosts. After this lesson, you should able to describe the concept of DHCP and describe the DHCP process. We will delve deeper into the DHCP protocol from the following two aspects: concept introduction of DHCP and DHCP interaction process. Here is the concept introduction of DHCP. The Dynamic Host Configuration Protocol, DHCP, is a protocol that dynamically provides configuration parameters for Internet terminals. When a terminal submits an application, the DHCP server can provide the terminal with parameters such as the LP address, gateway, and DNS server address. The basic DHCP protocol consists of three roles: DHCP server, DHCP client, and DHCP snooping or relay server, optional. On a TCP or IP network, each workstation must perform basic network configurations before accessing the network and its resources. Key parameters to be configured include LP address, subnet mask, default gateway, and DNS. The Dynamic Host Configuration Protocol, DHCP, is designed for this purpose. 1. DHCP can reduce configuration errors. The DHCP minimizes the number of errors caused by manual LP address configuration. For example, the possibility of allocating an LP address in use to another device is greatly reduced. 2. DHCP reduces network management workload. TCP or IP configurations are centrally and automatically completed without manual intervention by a network administrator. A network administrator can define the TCP or IP configurations of the global network and specific subnets in a centralized manner. The DHCP options can automatically allocate all additional TCP or IP values to clients. Client addresses must be frequently updated. For example, a remote access client may move everywhere and needs to be configured efficiently and automatically when it is restarted in a new location. Next, we will introduce the two main roles in the DHCP process. To understand the interaction process of DHCP, first we need to know the roles of DHCP server and DHCP client. First, let's talk about DHCP server. A DHCP server processes requests for address allocation, lease renewal, and release from clients or snooping or relays, and allocates LP addresses and other network configurations to clients. Next would be DHCP client. A DHCP client exchanges packets with a DHCP server to obtain the LP address and other network configurations. The DHCP protocol is used to dynamically obtain parameters, such as LP addresses, from the DHCP server, facilitating client configuration and centralized management. Here is the DHCP process between DHCP server and DHCP client. Next, I will introduce the most common DHCP packet. DHCP Discover. A client broadcasts this packet to discover available DHCP servers. DHCP Offer. A server sends this packet to respond to the DHCP Discover packet from a client and provides various configuration parameters to the client. DHCP Request. A client applies for an address and other configuration parameters from a server. A client checks whether the original address and other configuration parameters are correct after restart. A client applies to extend the lease term of the address and other configuration parameters from a server. DHCP-ACK. A server sends the address to be allocated and other configuration parameters to a client. DHCP-NAK. A server notifies a client that the requested address is invalid or has expired. DHCP Decline. A client notifies a server that an allocated address is being used by another device. DHCP Release. A client releases an address used by it. DHCP Inform. A client applies for local configuration parameters after an address has been allocated from a server. The following is the DHCP process in Wireshark packet capture. Following, let's learn how is DHCP used in the live network. On live networks, LP addresses are usually assigned from both local and remote address pools. The OLT organizes LPv4 addresses into an IPv4 address pool for management in either of the following modes. First, the local address pool is managed by the OLT. The OLT allocates, renews, and reclaims LP addresses in the local address pool. Second, the remote address pool is an image of the external DHCP server. Lieutenant does not contain the actual LP address, but specifies the DHCP server corresponding to the address pool. When a remote address pool is used, the OLT can initiate requests on behalf of users, or relay user requests to apply for, renew, or release LP addresses from the DHCP server. For example, DHCP snooping or relay. Next, we will begin the third part of this course, VLAN of Access Network Learning. Firstly, we need to understand the concept of VLAN. VLAN is a technology used to implement virtual workgroups and limit broadcast domains. It is widely used on Layer 2 switching networks. VSOL-PON access devices work at the second layer of the TCP or IP model and implement the access and isolation of a large number of users and the access, isolation, and forwarding of multiple types of services by using VLAN. This lesson describes the VLAN running on VSOL-PON devices, which are some differences from traditional VLAN. Access devices have a large number of users and provide multiple services such as HSL and VoIP. To enable the access devices to differentiate between different user services when they process user packets, service flows are defined at the access node. This is the most common uses of VLAN. Network segmentation. VLAN enable the segmentation of a network into smaller, isolated logical networks. This segmentation enhances network security by separating different groups of users or devices. It helps to control and restrict access to sensitive resources, preventing unauthorized access and reducing the attack surface. After this lesson, you should able to understand the types of VLAN on VSOL-PON system and understand the VLAN configuration on VSOL-PON system. In the VSOL access network, the communication mode of VLAN is the same as that within a traditional VLAN. Packets are forwarded by querying the MAC address table. If a port is not found in the MAC address table, a packet on the port will be considered unknown unicast and will be broadcast to all ports in the VLAN. If the MAC and port is found in the VLAN, the packet will be forwarded. VSOL Access Network VLAN are the extended applications of traditional VLAN on common broadband access devices. 1. There are 4 types of VLAN on ONU: tag, trunk, translation, and transparent. Following, we will explain them one by one. Second, there are 3 types of VLAN on OLT, which is same as traditional VLAN, and 2 extended attributes: access, trunk, hybrid, and VLAN translation and Q-in-Q. Following we will explain them one by one too. Here is the application topology. Tag mode is generally used in scenarios that directly connect to computers. Picture shows how to configure tag. The ONU VLAN type tag is not the same meaning as transitotal packet with VLAN ID tag. It's same as VLAN access mode, which mentioned in previous lessons. This follow describes how the ONU GE port with tag mode process packets. When untag packet from PC, ONU will default add a tag of the VLAN ID to the packet and forward to OLT. When the packet with the same VLAN tag come from OLT, ONU will remove the VLAN tag of packet and forward to PC. Here is the application topology. Trunk mode is generally used in scenarios that connect to switch, so it can transmit multi-VLAN IDS data traffics. Picture shows how to configure trunk. The ONU VLAN type trunk is the same meaning as transitotal packet with multi-VLAN ID tag. This follow describes how to process packets. When untag packet come from PC, switch will default add a tag of the VLAN ID to the packet and forward to ONU. When ONU received the packet from switch, and the VLAN tag in the ONU GE port trunk VLAN list, ONU will permit and forward the packet to OLT. When packet with the VLAN tag come from OLT, and the VLAN tag in the ONU GE port trunk VLAN list, ONU will permit and forward the packet to switch. When switch receive the packet come from ONU with the VLAN tag, then remove the VLAN tag and forward to the PC. Here is the application topology. Tag mode is generally used in scenarios that connect to switch. Between ONU and switch can transmit all VLAN IDS data traffics. Picture shows how to configure transparent. The ONU VLAN type transparent is the extended applications of traditional VLAN. This follow describes how to process packets. When untag packet come from PC, ONU will permit and forward the packet to OLT without VLAN ID. When untag packet come from OLT, ONU will permit and forward the packet to PC without VLAN ID. When packet with the VLAN tags come from switch, ONU will permit and forward the packet to OLT with VLAN IDS. When packet with the VLAN tags come from OLT, ONU will permit and forward the packet to switch with VLAN IDS. Here is the application topology. Translation is generally used in scenarios that connect to switch, while switch service VLAN is different with old service VLAN. Picture shows how to configure translation. In this case, left one is source VLAN, Write 1 is destination VLAN. For example, VLAN 100 is source VLAN, and VLAN 1000 is destination VLAN. The ONU VLAN type translation is the extended applications of traditional VLAN. This follow describes how to process packets. When ONU received the packet from switch, and the VLAN tag in the ONU GE port translation VLAN list, old VLAN. ONU will translate to new VLAN and forward the packet to OLT. When packet with the VLAN tag come from OLT, and the VLAN tag match in the ONU GE port translation VLAN list, new VLAN, ONU will translate to old VLAN and forward the packet to switch. VLAN types on OLT. VSOL Access Network VLAN OLT is same as traditional like access, trunk and hybrid. OLT default all PON port and uplink port in the hybrid mode, and all PVID is 1. PON system, there are 2 extended attributes: Q-in-Q and translation on OLT. Here is the application topology. You can see, in old uplink port, service VLAN is 200, and in ONU side service VLAN is 100. So in this case, alt translate VLAN 200 data to VLAN 100 and deliver to ONU. Picture shows how to config above config in VSOL OLT. In some network environment, the OLT belongs to private owner. The VLAN design will be conflict with the service provider. So we'll use this VLAN translation to avoid that. When packet with the VLAN tag come from ONU, and the VLAN tag match in the OLT PON port translation VLAN list, customer VLAN, OLT will translate to service VLAN and forward the packet to carrier network. When packet with the VLAN tag come from carrier network, and the VLAN tag match in the OLT PON port translation VLAN list, services VLAN, OLT will translate to customer VLAN and forward the packet to ONU. A Q-in-Q VLAN applies to a scenario when multiple LSPS use the same OLT to serve different users. The OLT forwards packets to different carriers according to the outer VLAN tag of the packets, and the LSPS differentiate users and provide different services based on the inner VLAN tag of the packets. Packets with 2 VLAN tags traverse the backbone network of a service provider and reach the BRAS for authentication based on double VLAN tags. User 1 sends an untagged packet to the ONU. ONU will add CVLAN 100 to OLT. When OLT receive packet with VLAN ID 100, the OLT adds SVLAN 10, CVLAN 100 and SVLAN 10 to ISP1. ISP1 sends double VLAN tags CVLAN 100 and SVLAN 10 packet to OLT. OLT remove SVLAN 10 and send to ONU. When ONU receive packet with VLAN ID 100, the ONU remove the CVLAN 100 to user 1. That's all for this course. Thank you for your attention and listening. Finally, there is the question and answer session. If you have any questions about this class, please leave a message here and we will reply as soon as possible.